Okay, let's get started. My name is Ram. I'm a software engineer at DataTorrent, the company that built Apache Apex to begin with. So today's webinar is going to cover the process of building your first Apex application. So a couple of brief words about what Apex can do. Apex is essentially a platform for building distributed applications on top of Hadoop. So Hadoop has two core components, a distributed file system called HDFS and a resource manager called Yarn. On top of that, Apex is a platform that lets you build distributed applications. One of the major uses of Apex is to deal with streaming data. So this is data that's contrasted with batch-oriented uses. So in a batch process, your data is at rest. It's in a file, or it's in a database, or some such repository. And it has a beginning and an end. So you start at the beginning, process the data, you reach the end, you stop, and the application is done. Streaming data is different because it has no beginning and no end. A couple of examples are data coming in from sensors on IoT devices, IoT meaning Internet of Things. So if you've got a power provider that has a windmill farm, every windmill has hundreds of sensors, and data from those sensors is constantly streaming in to their data gateway, and this data needs to be analyzed as it's coming in. You cannot wait until it's stored into some file. Another example is a clickstream on a popular website. If you have a website that's being accessed by millions of people all around the world, that website is going to be active and people are going to be clicking on various parts of it around the world 24/7, and that click data is going to come into your web servers continuously. So you need to be able to handle that streaming data as it is streaming in so that you can make changes based on audience interest, audience location, audience size, and so forth. So that's the major area of application for Apex as a platform. Distributed in this case means that it runs on a cluster, and your application is broken down into pieces called operators, and each operator runs potentially on a different cluster node. And all these operators communicate with one another by passing data back and forth via input and output ports. Okay, with that introduction, let's move ahead to the next slide. There's the outline of what we'll be covering today, the main concepts involved in an Apex application, brief description of the application that we'll be building today. It's called sorted word count. It reads data from an input file, breaks it up into words, and does a word count, and finally prints out a sorted list of the words and their frequencies, sorted by descending order of the frequencies. We'll start out with a hands-on demonstration of how to clone the Apex source repositories. Apex is, of course, open source. There are a couple of repositories, one for the core platform. It's called Apex Core. And the second is a library of pre-built operators that can save you quite a bit of time. when you're building an Apex application. And that library is called Malhar. The repository is called Apex Malhar. So we'll download those using Git and build them. Then we'll do a hands-on demonstration of how to create the new application and how to build it. And finally, we'll run the application and, if time permits, do a quick walkthrough of a couple of the operators and then answer any questions. The main concepts involved in an Apex application are operators, DAGs, and ports. So operators, as I mentioned before, are units of computation that can run, that each run in their own JVM, Java Virtual Machine, potentially on a different node in the cluster. Hang on 1 second. Okay, so, whoops. The slides I have here are very small in number, so we'll be done with this pretty quickly. The platform provides a base operator, which is provided as an easy way of implementing your operators, so you can extend base operator. All it does is provide empty implementations of all the required methods. Within an operator, you can define the necessary input and output ports, typically using, again, a couple of predefined classes called default input port and default output port. The application class implements the streaming application interface, and you only need to implement populate DAG. There's just one method in that interface. And that method is usually very simple. All it does is wire the operators together, connecting the output ports of one operator to the input port of the downstream operator. Applications typically process data within time-based windows. So a window is typically half a second, 500 milliseconds. These windows are not batch windows. They're just a convenience for the platform to manage the applications. So your data does not have to wait for the end of a window in order to process it and send it out to the next downstream operator. So incoming data, referred to sometimes as tuples or events, is processed as it comes in. There's no waiting involved, no artificial latencies created. Okay, the sorted word count application involves 5 operators. A line reader that reads a file that's dropped into an input directory and splits it up into lines and outputs them on its output port. The word reader does something similar, but with each line. It splits each line into words using a regular expression that defines what constitutes a separator between words. So it will use that regular expression to split the words out and output the words on its output port. The next downstream operator is window word count, which computes the word frequencies for all words that are processed in the current window. When it gets to the end of the window, it outputs the word counts that it has. In this particular case, we emit the data at the end of the window, but that's not a requirement. That's a convenience. File word count accumulates all the word counts for the current file and then emits the final sorted list when the end of file is reached. That list is sent to a word count writer. The word count writer writes the list to the output file in the configured output directory. So a diagram illustrating how these operators are connected to one another is in the form of a directed acyclic graph. The graph needs to be acyclic. Data cannot flow backwards. That's why it's acyclic, and it's directed because the arcs connecting the nodes have a direction. There's the upstream operator and the downstream operator. In this case, we see the 5 operators that I mentioned before, and data flowing from one to the other. Notice also that there's a control flow going from the line reader to the file word count. So you can have multiple ports on these operators. So in this case, the line reader has 2 ports, one for emitting the lines and one for emitting an end of file control tuple when it hits the end of file. So the file word count needs to know when the end of file has been reached so that it can write these sorted word counts. And that's the purpose of that control port. So the file word count has 2 input ports, one to receive the word counts from the window word count operator, and the other for receiving the control tuple, in this case the end of file marker. Okay, so with that introduction, I'm going to go ahead to the hands-on part. Here we have a terminal window on a virtual machine. So this laptop is running Windows, and on it I have Oracle VirtualBox running and a virtual machine that I've created running Ubuntu Linux. So if we go here and type lsb_release-a, it shows you the actual distribution that I'm running. It's Ubuntu 16.04.1 with the code name Xenial. Now, on this machine, I also have Hadoop installed. So that's a prerequisite. You need to have a number of things pre-installed. So the first thing, of course, is Java. So if you type java-version, it should show you that Java is installed. In my case, I have 1.8.0/101 installed. You need Maven. Maven is the build tool that we use for all projects that use Apex, and its command line command is mvn. So if you type mvn-version, it should show you the Maven version. Now I should mention that your Java install should not just include the JRE, the Java runtime environment, but it should also include the development kit, the JDK. One way of verifying that you've got the JDK installed is to type javac-version. And there it shows you the same version number. Finally, you also need Git installed. Git is a version management system. So if you type git-version, it'll show you the Git version. Once all these are installed, you can go to the Apache download site and download Hadoop and follow their instructions to install it. So once Hadoop is installed, you should be able to type Hadoop version, and that will show you the Hadoop version that's running. In my case, it's 2.7.2. Any recent version should be adequate. Once Hadoop is installed, you need to start both the HDFS daemon and the yarn daemons, following the instructions on the Hadoop website. And if you've done that, once you've done that successfully, if you type JPS, JPS is a command very similar to the PS command for listing the running processes on Unix systems or Unix-like systems. But JPS is similar, but it shows you only the Java processes that are running. So if I type JPS, you should see these processes running. In addition to JPS itself, you should see 5 processes running: name node, resource manager, node manager, data node, and secondary name node. If those are not running, then there's something wrong with your Hadoop installation that you need to fix before going ahead. One other check that you can do is once Hadoop is installed, you can go to a browser and go to localhost 50,070. If you go to that location, you'll see this page. This is the console for HDFS. And in that console, you'll see various pieces of data about when the daemons were started, the cluster ID, and so forth. An important thing to look for is this safe mode. It should say safe mode is off. So when the Hadoop daemons start, safe mode will be on, which means it won't allow any write access. And once it's all done and all the daemons are healthy, safe mode will be turned off. And a second check is to go to the yarn console. That's available at 8088, localhost :8088. If you go there, you'll see a page like this. So here it shows you in the lower part of the page the list of applications. So notice it shows one application with the status killed. This is an application I just started a few minutes before, just to verify that things are working okay, and then I killed it. So the status, the state is shown as killed. When we start additional applications, and we'll come back to this page, and we'll see that there will be additional rows for the applications we start. Okay, so let's go back here. I'm going to switch to a different console window, and here are here's a listing of my home directory on this machine. I'm going to create a new work directory called work and step into it. And of course, if I do an ls, there's nothing there. So the first thing we'll do is clone the Apex source repositories. So for that, if you go to GitHub, github.com, Apache/Apache Core, you can even just search for Apache Core, and you'll come to this page. This is the GitHub location for the core platform. So we can just pick up that URL, head back to our console, and do a git clone, and then my paste. I need to probably copy this. Copy. There we go. We have the URL, the git clone, and then the URL will clone the repo. So this will take about a minute or so while it downloads all the data, and it's done. So if I do an ls, you'll see there's a directory called Apache core. Let's do the same with the library called Nohar, and that has the same URL, except instead of core, you do Nohar. Okay, there we go. This will take a little bit longer because there's a lot more files in here. There's many operators that work as connectors to external systems. We support many different external sources of data, such as HDFS file systems, message queues, databases, and so forth. We'll talk about that shortly. Okay, so the cloning is done. Here's Apex core and Apex Nohar. There's also a repository that has a lot of sample applications. Let's go ahead and clone that as well. So Git Clone so if we go back to our browser, the repository is here. It's github.com/DataTorrent/examples. So let's just pick up that URL and paste it here. So there we are, github.com/DataTorrent/examples. This is a pretty small repository, so it should clone pretty quick. And there it is, it's done. All right, so we have 3 Git repositories cloned. What we'll do now is build the 2 Apex repositories. So I step into Apex core, and here's the files in there. You'll notice that there's a file called pom.xml. This is the build file that tells Maven how to build this project. You don't have to reference it explicitly. It will be automatically detected when you run the maven command. So the maven command we want to run is mvn clean install and then -d skip tests. So skip tests will skip the unit tests. There's a lot of unit tests, and they can take many minutes to run. We don't really need to do that here, so I do the -d skip tests. Clean will get rid of any old artifacts. Of course, there aren't any right now. And install will install the artifacts into my local repository. So typically, a local Maven repository is under the .m2 directory of the user's home directory. So the install is not installing anything to the system directory, so you don't need to be root or super user to do this. It's just installing to your home directory into a place typically named .m2 and within that. Okay, so let's go ahead and run this command. This can take a couple of minutes to run because Maven goes through and checks a lot of the dependencies and will download the dependencies if necessary. So you need to have an internet connection the first time you do this. After you've done it once, all the dependencies have been copied over into your local directory. So you'll be able to still work offline, but the very first time a net connection is necessary. So while this is going on, let me go over to the examples repo and point out a couple of things. So if we go here, under examples, there's a link called tutorials. So if you go to the tutorials link, this is the page you'll see. You'll see there's lots of directories there, and each directory is a self-contained sample application that illustrates one particular use case. So the Cassandra input shows you how to use the built-in Cassandra input operator to read from a Cassandra data store. The Cassandra output similarly shows you how to output data to Cassandra using Apex. There's examples for deduplication, partitioning, enriching, and several applications showing how to process files from HDFS, file IO simple, and so forth. File output shows you how to output files to HDFS, and so forth. So I strongly urge everybody to download this repository and go to the example that most closely matches your interest or your intended area of application, and go ahead and build it and run it. You can then make changes to it as well as necessary. Okay, so let's go back to our console here, and notice it's finished, and it tells me that the total time it took is just under 2 minutes. So we'll now do the same for Nohar. So /apex Nohar. And here again you see this pom.xml. That's the build file. We'll run the same command as before. Clean maven clean install -d skip tests. Now this one can take about a minute longer, so it might take about 3 minutes or so, because as I mentioned before, it has many more files that it needs to compile. Okay, so while that's in progress, let's go back here, and I'll point out one other site that's very useful when building Apex applications, and that is this one, docs.datatorrent.com. This is where we have a lot of documentation about the Apex core platform itself, a downloadable sandbox that you can use, various tutorials that show you how to build applications, and we also have documentation on some of the important operators. So here's the library operators. There's a manual for the Kafka input. There's one for dimensions computation. There's one for deduper. There's one for file output. And for large files, we have operators that allow you to split the file while reading into multiple pieces, and have different operators read different parts of the file to increase parallelism and throughput. So that's File Splitter. So you can look at those. We also have a troubleshooting section here. If you run into problems, this section is very useful. Large number of common problems are discussed. The Apex CLI is a command line tool that we'll be using today for monitoring applications and launching applications. So that's documented over here. a good place to start is this beginner's guide here. So I would strongly recommend to people to look at this beginner's guide and go through it once. It gives you a very good overview of various concepts of how to build applications, and it even gives you a walkthrough of some of the example applications. Okay, so let's head back to our terminal console and see how things are going. Okay, we have here a good part of the work is done, but it's now running this JAPI CMP, which is a Maven plugin that checks to make sure that any changes are not incompatible with the defined API. Okay, it should be done pretty soon. Let me move over to this other console and show you one other thing. Over here, our application is going to read data from an input directory on HDFS, and it's going to write the results also to HDFS, and we'll need to run the HDFS command to check those. So here's HDFS DFS/ls. This is the way you perform a listing on an HDFS directory. So directories relevant for our application is /tmp/test/input_dir. And there should be nothing there. It takes a few seconds to respond, and there, it's come back. There's nothing in that directory. And the output directory is output_dir, and there should be nothing there either. So once we run our application, what we'll do is we'll copy a text file over to the input_dir and let the application chug along for a minute or two while it processes that input file, and then do an ls on this output_dir to see if it's produced any output. Okay, so let's see what's happening with the Nohar build. There we go, it's completed, and it took 5 minutes. Okay, so both core and Nohar are now built. So let's move to the parent directory here. Now, in this examples repository, there is a small shell script called new app. So let's see if we can find it. There it is, examples, tutorials, top N word, scripts, new app. So if I copy that over here, we can take a look at it and even run it. So there's my new app script. Let's take a look at what's in it. So it's a simple shell script to create a new Maven project that will be based on Apex. So it's very simple. There's a couple of variables, the name of the project and the version. This is the version of the platform that we want to use. So this was done earlier, and the current version is 3.4.0, so I'm going to change that to 3.4.0. The rest of it can stay the same. It's a long Maven command, so I've broken it up into multiple lines. This command, by the way, is also given in the beginner's guide that I pointed out a minute ago. So you can use it from there as well. The -B says it's run in batch mode. So without that, you'll get a couple of questions on the console that you need to just hit enter for. So I avoid that by using the batch mode. And the rest of the arguments describe the type of Maven project that we want. So this is now ready to be run. So let's go ahead and save that and run this command. So I can run it by just saying bash new app. Bash is the shell and the argument is the script. So this should run and complete pretty quickly, a few seconds. Okay, it's successful. Now if I do an ls, you'll see there's a new directory there called my Apex app. Okay, so that's the new project that it's created. So let's go into that. And if we do an ls, there we see the usual pom.xml and the src directory, which contains the source files. So the new project that's generated also includes a couple of source files for a very simple project, for a very simple application. The application generates random numbers and outputs them to a console operator, which just writes them out to the console. So we can build this and run that application if we want, but what I'd like to do is to build the sorted word count application that I mentioned earlier. So to do that, we need to go into the directory that holds the source files. So if we do, for example, run a find command on source and look for Java files, you'll see that there's 3 Java files. One of them is just application test. It's a unit test for applications. But the other 2, the directory that holds the other 2 is where we need to go. So I'm just going to do a Ph.D. of source main java.com example my Apex app. And if I do an ls, you'll see there's the 2 source files. Now to save some time, I've prepared source files for our sorted word count application, and they are in the examples repository. So let's look at that. So okay, hang on one second. All right, so let's do tilde/work/ examples. Remember I mentioned there's a tutorials directory, and then under tutorials there's top N words, and under that there's webinar, and the desired source files are in that directory. So what I'm going to do is copy over all the Java files, star.java, from that location to here. Okay, so it's copied them over. Notice that we have a new application word count. This is the main application that has the populate DAG function that we talked about earlier. And then we have the file word count, line reader, window word count writer, and word reader. WC pair is a Java class that just holds a pair of values, the string that is the current word and its frequency. So this object will be transmitted between some of those operators, and that's why this class definition needs to be present here. Okay, so we have in that webinar location, notice that there's one additional file called properties sorted word count.xml. So this is a configuration file. It's an XML file that has various configuration values for this application. So we need to put that in the right place. And the right place is under resources. So let's go there, // // If I go to the main directory and do an ls, you'll see the Java directory, which has our source files, and then there's the resources directory, which has various non-source resources. So if we go in there, you'll notice this meta-inf directory. Let's step in there, and here's a properties.xml. So a single project can contain multiple applications. In our case, once we build this, you'll see that this project actually has two applications. The first default project that I mentioned that generates random numbers, and then the new sorted word application. So the properties that are common to all applications in a particular project are placed typically in this file called properties.xml under meta-inf, this guy right here. Okay. Now, if you have additional properties that are specific to a particular application, you can create additional properties files here, which are named by the word properties, followed by a hyphen, followed by sorted word count, the name of the application. In this case, sorted word count.xml. So we're going to copy that file over from its original location to this directory. So properties, copy that here. Okay, so we have the two properties files here. We're done with adding the necessary files for this application. So I now go back to my main directory of the project, and I'm ready to build this. How do we build it? Well, we build it the same way as we built the Apex platform, with one difference. In this case, this is an application project, so we don't need to install it. Typically, only libraries need to be installed in the local repository. So instead of the install, we'll run the same command, but replace install with package, because we just need the application packaged up. While I'm here, let me show you this local repository that I've been talking about. So as I mentioned, it's in the home directory of the user, and it's named .m2. So if I list that directory, you'll see it has a subdirectory called repository. We can list that, and you'll see there's a huge number of directories for all the dependencies. Okay, all right, so let's go to our maven command and replace that install with package, and it should build my application. This should also go pretty quick because there's just a small number of files to be built. And There we are. We're done. It took about 20 seconds to build. Now, if we do an ls, you'll notice that there's a new directory called target. That's the directory that holds the artifacts of the build process. So if I list the target, you'll see that there's a number of directories and files there, but the one that's of interest to us is this APA file. APA, or application package. And that file is actually a zip file or a jar file. So you can run the jar command to look inside and see what's there. But that's the package file that we'll use to actually launch the application. If you want to see what's in there, you can run jar tbf. The T stands for table of contents, and then give it target slash, there's only one APA file, so I can do star.apa. And there you see the contents. You see this meta-inf thing, a jar file, and then under lib, there are all these dependencies. Here's Malhar library, and a lot of these dependencies. And here's the properties file that we just copied over. Notice that in this list of jar files, there are no Hadoop jars. So that's something important that you should check for when you build your own applications. Because sometimes some Hadoop packages will end up pulling in Hadoop jars, and that will cause problems at launch time, because those jars will conflict with the ones that are already present. Okay, so we're now ready to launch our application. So to launch it, we need to use the command line tool called Apex that I mentioned before. So I'm going to go to Apex Core, and if I do a find here, there it is. It's under Engine Source Main Scripts Apex. So that's the command line command we want to run. Okay, so if I run that, it will give me a command line prompt. Okay, so it tells me what version of this tool I'm running, and there's the prompt. It has extensive built-in help, so you can just type help, and it'll show you all the various commands available. There's a lot of them, but what in is to launch the application. So if I do launch, I can then point it to the APA file. So the APA file is under my Apex app /target/ I can just use a wildcard and say star.apa. Okay, so here you notice that it's prompting me, showing the two applications that are present. One was the default and one was the new one we just created. So we want to run the new one, so I type 2 and hit return. And it should take a few seconds. It does a lot of work in this step, by the way. And there we go. it has successfully launched the application, and it gives me the application ID. This long string here is the application ID. So at this point, I can run list apps, and it will show me the applications that it knows about. So notice that it produces two records. One is the first one that I ran before the webinar started as a dry run that I then killed. So it shows the state of that application as killed. The second is the one we just ran, and it shows the state of that application as running. So our application is currently running. Now, you'll recall the Yarn console that I mentioned before. If we go here and then refresh this page, we should see the second application. There it is. Sorted word count is the name, and its state is shown as running. So everything seems to be in good shape. So I'm going to come over here and copy over the input file. So I have in my home directory, I have a directory called share, and there I have a text file called Pride and Prejudice. You can use any text file you want. This I downloaded from the Gutenberg project. It's a Jane Austen novel called Pride and Prejudice in text form. It's a fairly large file. You can see that it's got about 13,000 lines and almost 3/4 of a megabyte of data. Okay, so that's the file we're going to use, and the way we copy it is we say HDFS DFS put put Pride and Prejudice.txt, and we want to put it in /tmp/test/input dir. Recall that that was the input directory for our application, so the put command will copy it from the local file system to the HDFS file system. Okay, so let's give that a shot. It's done the copy, so if I run the ls command that we had before on the input directory, it should now show that it contains one file. There it is. That's the input. Okay, so let's now run the same ls command on the output directory to see if it's created an output file. Okay, it's created the file. It's got an extra suffix on it saying copying. The output operator, file output operator, will create a temporary file name that sometimes has a TMP extension on it, sometimes has this copying extension on it. And eventually, after a few minutes, once all the output is done, it will rename that temporary file to the configured name. In this case, it's the same name, but it's in a different directory, the output directory. Okay, so let's do the ls command again to see if the rename has happened. It generally takes a few minutes for that rename to happen. Let me point out here that the input file has a size of close to 3/4 of a megabyte, as I mentioned before, but the output file, oh, actually, I'm sorry, it's already created the renamed file. This copying file is just left over from its processing and will eventually get deleted. But this file right here, Pride and Prejudice.txt, in the output directory is the file that we want. Now notice that that file, the size is only 89K. And that makes sense because it only has the words and their frequencies in descending frequency order. Okay, so let's look at that file. And the way you look at that file is by saying cat and then naming the file. Now, it's got a lot of lines, so to limit the amount of output on our console, I'm going to pipe it to head, which will just print the first few lines. So that should be a list of the most frequent words. There we are. So the application has run successfully, and it shows you that the article "the" is the most common word in this text. That's to be expected. And then comes the word "to" and "of," and all these conjunctions and prepositions in English that tend to occur fairly frequently. As an exercise, I would suggest to everybody to go into this application and see if you can exclude these common words so that you get a better idea of the word frequencies of the unusual. That would be a good exercise to do. Okay, so let's go and take a quick look at the configuration files. We're here in this Apex command line application, and if I do a list apps, it still shows the application is running. So it continues to run and monitors the input directory and copy another file there, and it will process it, and one more file, and keep going that way. Okay, so I can also kill the application here by typing kill app, and it will kill the current application. So if I now do list apps, it shows both applications as being killed. All right, so if you type exit, you get out of here. All right, so let's go back to our application and go to main, resources, and look at the properties. Okay, so here's the properties file. So here we see every property is defined by an XML property element with a name element and a value element. So this property allows you to pass additional JVM options to each operator. For instance, you could pass in maximum memory, minimum memory, all those sorts of things. But this property is actually commented out. It's just here's a sample to show you what's possible. So here's a more interesting property. This is actually not commented out, so it's active. It shows you that the regular expression that separates words. So here's the regular expression. It says any punctuation or any white space, one or more occurrences of those things, will separate words. So this is the regular expression it uses. You can play around changing the regular expression here to see what effect it has on the application. So if moving ahead, recall that the word reader is the one that splits lines into words, so that's the one we configure with this regular expression. The line reader needs to know what directory to monitor, so we configure the directory property to be /temp/test/input_dir, which is what we used on the command line to copy the input file. The word writer needs to know the output directory, and that's right here, output_dir. This configures the amount of memory in megabytes for the application master. So there's one additional process that runs, called the application master for any Yarn application, and that's a supervisory process that monitors all the other operators in your application. So that's the memory configuration for that operator, or for the application master, I meant to say. Here's the memory configuration MB for all other operators. So notice here we say we use wildcards in the name. So it says for all applications in this package, and for all operators, use 128 megabytes as the memory. Now, if you want to specify different values for the different applications, you can do that. So, and so on down the line. So if we there's also an internal thing called a buffer server used to buffer tuple data on output ports, and that that component has a certain amount of memory required, and that's configurable by using the attribute name buffer memory MB, and we've used 128 here. We've used small numbers because this is a standalone virtual machine with a limited amount of resources, but on a typical cluster, these values will be pretty large, like a half a gigabyte here, and maybe operator memory will be 1 to 2 gigabytes each, maybe larger, depending on your application. All right, it looks like we've run out of time, so we've completed the application and we've run it, supplied an input file, checked the output file, and finally terminated the application. I hope you enjoyed the seminar, and happy apexing. Thank you, everybody.